Question number 8 asks us to find and identify all relative extrema given that function for f of x. Extrema, remember, mins and maxes, they occur when the first derivative changes sign. So we are going to take the first derivative of that. We have to use the product rule. So product rule is the derivative of one times the other one. So that would be 3 times x minus 2 to the second. So I moved the 3 out front. I subtracted 1 from the exponent. Chain rule says times the derivative of the inside, but that's just 1, so I don't need to worry about that. So that's the derivative of the first one times the second one plus the first one, x minus 2 cubed, times the derivative of the second one. The derivative of x minus 1 is just 1. So we set that equal to 0 and then solve. To solve this, we are going to factor out the common factor between the two terms, which is x minus 2 squared. So I took out this x minus 2 squared, so I'm left with 3 times x minus 1. For this term, I took out x minus 2 squared, and I started with x minus 2 cubed, so I'm left with just x minus 2 to the first. I am going to distribute and combine like terms. 5x, 4x minus 5, and x minus 2 squared. Set that equal to 0 and solve for x. So I get x equals 2 or x equals 5 over 4. Our first derivative is never undefined. We don't need to worry about that. We could use the second derivative test and find the derivative again and plug those in. I think it's way easier to just use the first derivative test. It doesn't tell us how we have to do it. So we are going to set up intervals with our first derivative, going from -infinity to 5/4, from 5/4 to 2, and from 2 to infinity. Pick a value on each interval. So from -infinity to 5/4, if we plug in 0, I'm going to plug it into the derivative, which is the same thing as this. That's the factored form of the derivative. So if I plug in 0 here, I get 4 times -5. That's negative. If I plug in 1.5, 1.5, 1.5 minus 2 squared, because I'm squaring it, I get positive. Here I get 6 minus 1, which is positive. Positive times positive is positive. And feel free to use a calculator when you plug these in. If we plug in something from 2 to infinity, if I plug in 100, I get positive and positive. So at 5 over 4, my derivative changed from negative to positive, which tells us that we have a relative minimum. The graph was decreasing, and now it's increasing. That's going to be a minimum value. The x value of that minimum is 5 over 4. At x equals 2, I have no sign change in my derivative. That is neither a min nor a max. We are listing out our points where we have relative extrema, so we don't need to worry about that one. I just need the y value of that relative minimum. So we are plugging 5 over 4 back into the original equation. So 5/4 is my x value, and the y value is -0.105.